Hello everyone, welcome to this video on error handling and debugging with the request library in Python. When working with APIs and web servers, things don't always go as planned. Requests can fail due to network issues, server errors, or invalid responses. In this video, we'll explore how to handle these scenarios gracefully using the request library. From managing common errors like timeouts and connection problems to implementing robust debugging techniques, this session will equip you with the skills to make your applications more reliable and user friendly. Let's get started. Common errors in the request library. When working with the request library, it's important to handle potential errors that may occur during HTTP requests. These errors can result from network issues, server problems, or invalid URLs. By using Python's built-in exception handling mechanism, you can manage these errors gracefully and ensure your program remains robust and user-friendly. 1. Connection error. One of the most common errors is the connection error. This error is raised when a network-related issue prevents the request library from successfully connecting to the specified server. For instance, problems like DNS failures, refused connections, or invalid URLs can trigger this exception. To handle such scenarios, you can use a try except block to catch the connection error and take appropriate action. In the example, the request.get method is used to send a get request to https://invalid-url.com, which is an invalid URL. Since the URL is not valid, the request library is a connection error. The try block attempts to execute the request, and when the error occurs, the except block catches the connection error and prints a user-friendly message such as failed to connect to the server. This ensures the program doesn't crash and provides clear feedback to the user about what went wrong. Handling errors like connection error is crucial when working with web applications or APIs as it helps you manage unexpected scenarios gracefully. For example, if a server is temporarily down or a URL is misconfigured, proper error handling allows you to retrace the request, log the issue, or notify the user without disrupting the flow of your program. In summary, understanding and handling common errors like connection error in the request library is an essential skill for building reliable Python applications that interact with web services. By using exception handling effectively, you can make your code more resilient and provide a better user experience. 2. Timeout. When making HTTP requests with the request library, there are scenarios where a server may take too long to respond. In such cases, the request library allows you to set a timeout period, ensuring that your program does not hang indefinitely while waiting for a response. If the request takes longer than the specified timeout period, a timeout exception is raised. Handling this exception ensures that your program remains responsive and doesn't waste resources on unresponsive servers. In the example, a GET request is sent to https://example.com and the timeout argument is set to 1 second. This means the program will wait for the server's response for up to 1 second. If the server fails to respond within this time frame, the request library raises a timeout exception. The try except block is used to catch this exception and handle it gracefully. When the exception occurs, the program prints a clear message the request timed out, letting the user know that the server took too long to respond. Using the timeout argument is especially useful in applications where responsiveness is critical, such as real-time systems, data pipelines, or user-facing applications. It ensures that your program doesn't get stuck waiting for a response from an unresponsive server, which could degrade the overall performance of your application. In summary, setting a timeout period and handling the timeout exception is an essential best practice when working with the request library. It helps you maintain control over your program's behavior, ensures efficient use of resources, and provides a better user experience by avoiding unnecessary delays. 3. HTTPError. When making HTTP requests using the request library, it is important to handle cases where the server returns an invalid HTTP response. These responses typically have status codes in the 4xx range client errors or 5xx range server errors. The request library provides a convenient way to detect and handle such errors through the HTTPError exception. In the example, a GET request is sent to https://example.com /404, which simulates a URL that returns a 404 not found response. The request.get method fetches the response, and the response.raise underscore for underscore status method is called to check the status code. Check the status code. If the status code indicates an error, e.g., 404 or 500, the raise underscore for underscore status method raises an HTTPError exception. The try except block is used to catch the HTTPError and handle it gracefully. When the exception occurs, the program prints an error message that includes details about the HTTP error, such as the status code and the reason. For example, in this case, the output might be HTTP error occurred 404 client error not found for URL https://example.com /404. Handling HTTP error exceptions is particularly useful when working with APIs or web services that may return errors under certain conditions. For instance, a 404 not found error might occur if a resource is missing, while a 500 internal server indicates an issue on the server side. By handling these errors, you can provide meaningful feedback to the user, log the issue for debugging, or take corrective actions such as retrying the request. In summary, the HTTPError exception and the response.raise underscore for underscore status method are valuable tools for detecting and managing invalid HTTP responses. By incorporating proper error handling into your code, you can make your applications more robust, reliable, and user-friendly when interacting with web servers. Using try except for robust error handling. When working with the request library to make HTTP requests, it's essential to implement robust error handling to ensure your application can gracefully handle unexpected issues. Using try except blocks is a reliable way to manage potential errors such as invalid HTTP responses, network connectivity issues, or timeouts. This approach not only prevents your program from crashing but also provides meaningful feedback to users or developers about what went wrong. In the example, a GET request is sent to https://example.com /API, and a timeout of 5 seconds is specified using the timeout argument. The response.raise underscore for underscore status method is called to check the status of the HTTP response. If the server returns an error status code, such as 4xx client errors or 5xx server errors, the raise underscore for underscore status method raises an HTTPError exception. The try except block is structured to handle various types of errors. If an HTTPError occurs, such as a 404 not found or 500 internal server error, a detailed error message is printed to help identify the problem. If a connection error arises due to network issues, such as DNS failures or server unavailability, a specific message indicates the network problem. Similarly, if the request exceeds the specified timeout period, a timeout exception is raised and a message informs the user about the delay. Additionally, a generic exception block catches any other unexpected errors, ensuring that the program handles all possible scenarios. This layered error handling strategy ensures that your application remains resilient and provides clear feedback in different situations. For example, users can be informed about connectivity issues, developers can log detailed error messages for debugging, and automated systems can trigger retrace or fallback mechanisms. In summary, using try except blocks for robust error handling is the best practice when working with the request library. It allows you to anticipate and manage different types of errors gracefully, making your code more reliable, user-friendly, and easier to maintain. Working with response codes. HTTP response codes are an integral part of web communication, providing insight into the status of an HTTP request. These codes, returned by the server in response to a request, indicate whether the request was successful, encountered an error, or requires further action. The request library in Python makes it easy to work with response codes through the status underscore code attribute, which allows you to determine the outcome of a request and take appropriate actions. For example, when making a GET request to https colon double forward slash json placeholder.typico.com forward slash post forward slash one, the server returns an HTTP response with the status code. If the status code is 200 OK, indicates that the request was successful and the server has returned the requested resource. In this case, the program prints a success message request successful. If the status code is 404 not found, it means that the requested resource does not exist on the server. This might happen if the URL is incorrect or the resource has been deleted. The program handles this scenario gracefully by printing resource not found. For any other status code, the program prints a generic error message including the specific status code. For instance, a 500 internal server error indicates that the server encountered an issue while processing the request, which is typically unrelated to the client's request and points to a problem on the server side. Handling response codes effectively allows you to provide meaningful feedback to users and implement appropriate logic in your application. For instance, you might retry a failed request, log the error for debugging purposes, or display a user-friendly message explaining the issue. In summary, understanding and working with HTTP response codes is crucial for building robust applications that interact with web servers. The status underscore code attribute in the request library provides a simple and reliable way to determine the outcome of a request, enabling you to handle success and failure scenarios effectively. Logging request and response information. When working with HTTP requests in Python, logging request and response information is an essential practice for debugging and troubleshooting. By capturing key details such as the URL, status code, and response body, you can gain valuable insights into the behavior of your application and quickly identify issues. The logging module in Python provides a simple and effective way to implement this. In the example, the login.basicconfig function is used to configure the logging system. The level logging.info parameter ensures that informational messages such as details about the request and response are captured. This setup allows you to log critical information during the execution of your program. A GET request is sent to https colon double forward slash json placeholder.typico.com forward slash post forward slash one using the request.get method. If the request is successful, key details are logged. Request URL, the actual URL used in the request accessed via response.url. This helps confirm that the request was sent to the correct endpoint. Response code, the HTTP status code returned by the server, accessed via response.status underscore code. This indicates whether the request was successful, e.g. 200 OK, or encountered an issue, e.g. 404 not found. Response body, the content of the response accessed via response.text. This provides the raw data returned by the server, which can be invaluable for diagnosing issues or verifying the response. The try except block ensures that any exceptions such as network errors or invalid OLs are caught and logged using login.error. This captures the exception details and provides clear feedback about what went wrong, making it easier to debug issues. Using logging for request and response information is particularly useful in production environments where errors may not be immediately visible. It allows you to maintain a record of application behavior, track down intermittent issues, and improve overall reliability. In summary, logging request and response details with Python's logging module is a best practice for debugging and monitoring HTTP interactions. It provides a clear and systematic way to capture critical information, helping you build more robust and reliable applications. Practical examples. 1. Handling invalid API responses. When working with APIs, handling invalid responses is an essential aspect of building robust applications. Invalid responses often occur when the API endpoint is incorrect, the requested resource does not exist, or the server encounters an issue. The requests library in Python provides a convenient way to detect and handle such cases using the response.raise underscore for underscore status method. This method raises an HTTP error string if the response contains a 4xx client error or 5xx server error status code. In the example, a GET request is sent to https colon double forward slash json placeholder dot typico dot com forward slash post forward slash invalid and intentionally invalid URL. The try block executes the request and uses response.raise underscore for underscore status to check if the server's response indicates an error. If the response contains a client or server error, such as a 404 not found or 500 internal server error, the raise underscore for underscore status method raises an HTTP error exception. The accept HTTP error block catches this exception and provides a meaningful message, such as invalid response 404 client error not found. This feedback helps identify the specific issue with the request, such as an incorrect endpoint or a missing resource. Additionally, a generic except exception block is included to catch other unexpected errors, ensuring that the program can handle all potential issues gracefully. If no errors occur, the program processes the response by converting the returned JSON data into a Python dictionary using response.json and prints it. However, in this case, the invalid endpoint results in a 4.4 not found error, demonstrating how the error handling mechanism works. This approach ensures that your application can respond appropriately to invalid API responses, providing clear feedback to users or developers and preventing crashes. By anticipating and managing such scenarios, you can create more reliable and user-friendly applications that handle errors effectively. In summary, handling invalid API responses with try except blocks and the raise underscore for underscore status method is a best practice when using the request library. It allows you to detect errors, provide meaningful feedback, and maintain the stability of your application even when interacting with unreliable or unpredictable APIs. 2. Retry logic with exponential backoff. When interacting with APIs or web servers, network issues and temporary server outages can sometimes lead to failed requests. In such cases, implementing a retry mechanism can help ensure that your application can recover gracefully and eventually succeed in making the request. Exponential backoff is a widely used retry strategy that progressively increases the waiting time between retries, reducing the risk of overwhelming the server while giving it time to recover. In the example, a GET request is sent to https colon double forward slash example.com forward slash API. The request is wrapped in a loop that allows up to 5 retries. If the request fails due to a connection error or timeout, the program calculates the wait time using exponential backoff. The waiting time doubles with each retry, starting from 1 second to 0 and increasing to 2, 4, 8, and 16 seconds in subsequent retries. The try except block handles the possible errors. 1. If a connection error or timeout occurs, the program prints an error message indicating the issue and the waiting time before the next retry. The time.sleep function pauses execution for the calculated duration. 2. If an unexpected error occurs, it is caught by the generic except exception block, which prints the error and exits the loop. 3. If the request is successful indicated by no exceptions and a valid response, the loop breaks and the program prints a success message. This strategy ensures that your application doesn't repeatedly bombard the server with requests in a short period, which could worsen the problem or result in throttling. Instead, exponential backoff provides a controlled and systematic way to retry, improving the likelihood of success while minimizing unnecessary load on the server. In summary, implementing retry logic with exponential backoff is a robust method for handling temporary network or server issues. It enhances the resilience of your application by allowing it to recover from transient failures while maintaining efficient use of resources. By combining error handling with intelligent retry mechanisms, you can build applications that are more reliable and better suited for real world scenarios. And that wraps up our video on error handling and debugging with the request library. Today we covered how to manage common errors like connection error, timeout, and HTTP error, and learned how to use logging and retry logic to handle issues effectively. By incorporating these techniques, you can make your applications more robust, resilient, and better equipped to deal with real world scenarios. Thank you for watching. If you found this video helpful, please like, share, and subscribe for more Python tutorials. See you in the next video.